Your brake warning light just came on, but your brakes feel completely normal. The pedal's firm, stopping power is excellent, handbrakes released, yet that red light is screaming at you from the dashboard. Most drivers ignore this, thinking if brakes work, everything's fine. That's a $2,000 mistake waiting to happen. Here's what nobody tells you about brake warning lights. They're not just monitoring your brake pads. Modern vehicles have sophisticated brake monitoring systems tracking everything from fluid levels to pad wear sensors to ABS communication. When that light activates, your car's computer detected something specific, and ignoring it can lead to complete brake system failure. I've been working on brake systems for over 15 years, and the number of perfectly functioning brakes that failed catastrophically because owners ignored warning lights would shock you. That little red light isn't crying wolf. It's your car's way of saying, Houston, we have a problem. Most repair shops will run you through a $150 diagnostic fee, then hit you with repair estimates that make your wallet weep. Today, I'm revealing the exact 5-step diagnostic process that professionals charge $150 just to perform, and one of these steps reveals a problem that 90% of mechanics completely miss on the first visit. By the end of this video, you'll know exactly what's triggering that light, whether you can fix it yourself, and when you absolutely need professional help. Plus, I'll show you the diagnostic step that saved one of my viewers from a $1,800 brake system replacement. This works on everything from a 2005 Honda Civic to a 2024 BMW X5. Most people check their brake fluid level and think they're done. They're missing the most critical part, and it's costing them hundreds in unnecessary repairs. 3 weeks ago, I got a call from my neighbor. Her brake light had been on for weeks, but she'd checked the fluid level 5 times, always between minimum and maximum. She was ready to take it to the dealer until I showed her something she'd never considered. The brake fluid looked perfect, but the electrical system monitoring that level was failing. See, your brake fluid reservoir has a small float mechanism with electrical contacts. When fluid drops, the float drops, contacts close, and your warning light activates. But here's what happens that catches everyone off guard. Those contacts corrode, stick, or the float gets contaminated with brake fluid residue. Let me show you how to test this properly, and it's something you can do right now in your driveway. First, remove the brake fluid reservoir cap carefully. You'll see a small plastic float attached to the cap. Clean around the contacts with electrical contact cleaner. If you don't have that, isopropyl alcohol and a small brush work perfectly. Second, with the cap removed and your key in the on position, gently lift and lower the float. The brake light should turn on and off correspondingly. If it doesn't respond, your float system needs replacement. This is where most people give up and head to the mechanic, but stick with me. Third, check the brake fluid quality while you're here. It should be relatively clear, not dark brown or black. Contaminated fluid can cause float mechanism problems and indicates bigger issues brewing in your brake system. For most vehicles, replacing a faulty float mechanism costs $15 to $30 in parts and takes about 20 minutes. The dealer will charge you $200 to $300 for the exact same repair. However, there's a critical safety note here. If your brake fluid level is actually low, don't just top it off. Low brake fluid indicates a leak somewhere in your system, and that needs immediate professional attention. But what if your float system tests perfectly and your fluid level is fine? That brings us to the second most common cause that stumps even experienced mechanics. Your car knows your brake pads are wearing out before you do, but only if this tiny sensor is working properly. Most people have never even heard of these sensors, yet they're installed on millions of vehicles. Last month, a viewer sent me a message about his BMW. He was convinced the brake warning system was broken because his pads looked fine through the wheel spokes. Fluid was perfect, but the light stayed on. After walking him through this diagnostic step, we found a worn brake pad sensor worth $15. Without that sensor warning, he would have driven until metal-on-metal contact destroyed his rotors, turning a $200 brake pad job into a $1,200 disaster. Brake pad wear sensors come in 2 varieties. 2-wire systems continuously monitor pad thickness using electrical resistance. Single-wire systems create an open circuit when the pad wears to replacement level. Both serve the same purpose, protecting your rotors from expensive damage. Here's how to check yours, and the process is simpler than most people think. For European vehicles like BMW, Mercedes, Audi, and Volkswagen, sensors are typically on the front wheels. Look for a thin wire running to your brake pads. If you see a wire that's been cut or damaged, that's your culprit right there. For Japanese and American vehicles, wear sensors are less common, but increasing on luxury models. Check your owner's manual or look for wires running to the brake calipers. The key is knowing where to look, and most people search in the wrong places. Testing requires a basic multimeter, something every car owner should have. With the sensor disconnected, a good 2-wire sensor shows specific resistance values, usually between 1 to 3 ohms. A single-wire sensor should show continuity when new and open circuit when worn. Here's the part that trips up most people. Brake pad sensors must be replaced whenever you change brake pads. Even if the old sensor tests good, reusing it often causes false warnings because the sensor element has been stressed during pad wear. It's like trying to reuse a fuse after it's blown. Professional tip that could save you a comeback trip. If you're getting intermittent brake warnings that come and go, check for loose sensor connections. Road vibration can cause poor electrical contact, triggering false warnings that make you think your brake system is failing when it's actually perfectly fine. But sensors and fluid levels aren't the only culprits. There's a more sinister problem that can develop slowly over time, giving you no warning until it's almost too late. The master cylinder can be slowly failing while your brakes still work perfectly until they don't. This is the nightmare scenario that keeps brake technicians awake at night. Here's a case that still gives me chills. A pickup truck owner contacted me because his brake light would flicker going up hills but disappear on flat roads. He thought it was electrical gremlins, maybe a loose wire or bad connection. After some investigation, we discovered his master cylinder was developing internal pressure leaks that only showed up under load. The brake pedal felt completely normal during regular driving, but the system was one emergency stop away from complete failure. This is why master cylinder problems are so dangerous. They're silent until they're catastrophic, and by then you're facing a much bigger repair bill. Here's how to assess your master cylinder without expensive professional equipment, using tests you can perform right now. Start with the pedal behavior test. With your engine running, press and hold the brake pedal with moderate pressure. The pedal should remain firm and not slowly sink toward the floor. If it sinks, you have internal master cylinder leakage. Next, perform a visual inspection that most people skip. Remove the brake fluid reservoir cap and look inside carefully. You should see 2 or 3 separate chambers divided by rubber seals. If brake fluid is moving between chambers when you press the pedal, the internal seals are failing. Try the pressure consistency test next. With your vehicle on level ground and engine running, press the brake pedal 10 times with consistent pressure. The pedal should feel identical each time. Variations in pedal feel indicate internal problems developing. Finally, perform load testing on a safe, empty road. Make several moderate stops from 30 miles per hour. If your brake warning light comes on during braking but disappears afterward, suspect master cylinder internal failure. This test simulates the conditions where internal leaks become apparent. Here's the cost reality that nobody talks about. Early detection of master cylinder problems costs $200 to $400 for replacement. Emergency replacement after system failure can cost $800 to $1,200 because you'll also need brake fluid flushing, possible ABS system bleeding, and potential damage to other components. Critical safety note that could save your life: if your brake pedal sinks to the floor or if you experience any loss of braking power, stop driving immediately. This indicates imminent brake system failure, and continuing to drive puts you and others at serious risk. But mechanical problems aren't the only thing that can trigger brake warnings. Modern vehicles have computer-controlled brake systems, and sometimes the computer lies to you. Modern brake systems aren't just mechanical anymore. They're computer-controlled, and computers can give false warnings that lead you down expensive diagnostic rabbit holes. Here's a case that stumped 3 different repair shops, costing the owner hundreds in diagnostic fees. A Honda Accord owner had a brake warning light that would come on randomly, but every mechanical test showed perfect results. Brake pads were fine, fluid was clean and full, master cylinder tested good, everything looked perfect, yet the light persisted. The problem wasn't mechanical at all. It was a dirty ABS wheel speed sensor creating false signals that triggered the brake warning system. The car's computer thought one wheel was locking up or spinning differently, so it activated the brake warning as a safety precaution. Simple problem, but it took professional diagnostic equipment to identify. ABS wheel speed sensors are magnetic pickup units that monitor wheel rotation constantly. When they get contaminated with road grime, metal particles, or corrosion, they send erratic signals to your ABS control module. Your car's computer interprets these bad signals as brake system problems. Here's how to check and clean them, and this is something most people can handle with basic tools. Speed sensors are typically mounted near the wheel bearing or CV joint area. Look for a wire harness leading to a small sensor positioned close to a toothed ring on the wheel assembly. Start with a visual inspection after removing the wheel. Look for obvious damage, loose connections, or heavy contamination on the sensor tip. The sensor should be positioned with a small air gap between it and the toothed trigger wheel. If you see metal particles stuck to the sensor, that's likely your problem. For basic cleaning, use brake cleaner and a soft brush to carefully clean the sensor tip and the toothed trigger wheel. Don't use aggressive solvents or steel brushes that could damage the sensor. These sensors are more delicate than they appear. Electrical testing requires a multimeter, but the process is straightforward. Test the sensor resistance with the sensor disconnected. Most speed sensors should show 800 to 1,200 ohms of resistance. Readings outside this range indicate sensor replacement is needed. Here's something most people don't know that could save you a trip to the shop. Modern vehicles store ABS-related trouble codes even when the ABS light isn't on. Use an OBD2 scanner that can read ABS codes. Common codes like C0035, C0040, C0045, C0050 indicate specific wheel speed sensor problems. Electronic brake distribution systems can trigger brake warnings even when your traditional braking system is perfect. These systems use ABS components to automatically adjust brake pressure to different wheels, and sensor problems can cause brake warning activation without any mechanical brake issues. Professional tip that most mechanics won't tell you. If your brake warning light comes on during cornering, wet weather, or hard acceleration, suspect ABS integration issues rather than mechanical brake problems. The timing of when the light appears gives you clues about the real cause. But electronic problems aren't limited to ABS sensors. Sometimes the issue is as simple as corroded wiring, but finding it requires methodical detective work. Sometimes your brake warning isn't about brakes at all. It's about electricity lying to your dashboard, and these problems can drive you absolutely crazy. The most frustrating case I've encountered was a Toyota Camry, where the brake light only appeared during rain. The owner had checked everything multiple times, spent money at 2 different shops, and was convinced the car was possessed by electrical demons. After systematic diagnosis, we found corroded wiring behind the brake fluid reservoir. Water was penetrating a connector during rain, creating false, low fluid signals. The repair cost $35 in parts, but finding the problem required methodical electrical diagnosis that took hours. Common wiring failure points in brake systems include areas you'd never think to check. The reservoir connector, located behind or beneath the brake fluid reservoir, is exposed to engine heat and road splash. Corrosion here causes false fluid level warnings that make you think your brake system is failing. ABS harness roding presents another problem. ABS wiring runs near suspension components where it's subject to flexing, road debris, and salt exposure. Damaged ABS wiring can trigger brake warnings that have nothing to do with your actual brake performance. Ground connections cause some of the most mysterious problems. Brake system electrical components share ground connections with other systems. Poor grounds can cause intermittent warnings that seem completely unrelated to actual brake conditions. A Firewall penetrations where brake system wiring passes through present another failure point. Rubber grommets can deteriorate over time, allowing water intrusion and corrosion that creates intermittent electrical problems. Here's how to inspect brake system wiring systematically. Start with visual inspection, looking for obvious damage, abraded insulation, or corroded connections. Pay special attention to areas where wires bend or contact metal surfaces. These are the most likely failure points. For connection testing, disconnect electrical connectors and inspect for green corrosion or white powdery deposits. Clean connections with electrical contact cleaner and apply dielectric grease to prevent future corrosion. This simple step prevents many electrical problems. Continuity testing uses a multimeter to test wire continuity from component to component. Intermittent connections may test good when stationary, but fail under movement or vibration. This is why electrical problems can be so frustrating to diagnose. Ground verification requires testing voltage between component grounds and battery negative. Readings above 0.1 volts indicate ground problems that can cause multiple electrical issues throughout your brake system. Professional boundary note that could save you money and prevent damage. Complex electrical diagnosis involving ABS control modules or integrated brake systems requires professional-grade diagnostic equipment. Attempting advanced electrical repairs without proper tools can damage expensive electronic components that cost thousands to replace. Now that we've covered all 5 diagnostic steps, let me give you the systematic approach that works every time. Here's your complete brake warning light diagnostic checklist that will solve 95% of brake warning problems. This systematic approach saves time and prevents you from chasing expensive red herrings. Start with step 1, verifying brake fluid level and float system operation. Test the float mechanism and clean electrical contacts. This costs nothing to $30 and takes about 15 minutes. Most brake warning lights are caused by this simple problem. Move to step 2, testing brake pad wear sensors if your vehicle is equipped. Locate sensor wires and test electrical continuity. Replacement sensors cost $15 to $50, and the job takes about 30 minutes per side. European vehicles almost always have these sensors. Step 3 involves assessing master cylinder condition through pedal behavior testing and visual inspection. Testing costs nothing, but replacement runs $200 to $400. This takes about 45 minutes for complete diagnosis and is critical for safety. Step 4 checks ABS system integration by cleaning wheel speed sensors and scanning for trouble codes. Cleaning costs nothing to $25, while sensor replacement runs $80 to $150 each. Allow about 1 hour for complete ABS diagnosis. Step 5 inspects electrical connections for corrosion and damage. Cleaning supplies and connectors costs $10 to $50, but this can take 1 to 2 hours depending on what you find. Electrical problems require patience and systematic approach. DIY capability breaks down into skill levels that determine what you should attempt. Beginners can safely handle steps 1, 2, and basic visual inspection of step 5. These are the most common problems and the safest to diagnose. Intermediate DIYers can tackle steps 1, 2, 4, and complete step 5. This covers about 85% of brake warning light causes and requires basic electrical knowledge and tools. Advanced DIYers can handle all diagnostic steps, but should still seek professional help for internal master cylinder work. Some jobs require specialized tools and experience that make professional service worth the cost. Professional help becomes non-negotiable when you experience brake pedal sinking to the floor, complete loss of braking power, master cylinder internal seal replacement, ABS control module diagnosis, or complex electrical system integration issues. The cost-benefit analysis strongly favors early diagnosis. DIY diagnosis costs $25 to $100 in tools and supplies. Professional diagnosis runs $150 to $250. Early problem detection saves $500 to $2,000 in prevented damage, while ignored warning lights can cost $1,200 to $3,000 in brake system damage. Understanding your limitations isn't admitting defeat. It's ensuring your safety and preventing expensive mistakes that can cost you thousands more than professional diagnosis. Immediate professional attention becomes required if you experience any of these symptoms. Brake pedal goes to the floor indicates massive system failure. Grinding noises during braking means metal-on-metal contact is destroying your rotors. Vehicle pulls hard to one side during braking suggests caliper problems or brake hose failure. Brake fluid leaks visible under your vehicle indicate pressure loss that can cause complete brake failure. Complete loss of brake assist, where you have a hard pedal with poor stopping power, suggests power booster failure or vacuum system problems. Professional diagnosis becomes recommended for intermittent problems that you can't reproduce consistently. These are the most frustrating problems because they seem to disappear when you try to show someone else. ABS warning lights combined with brake warnings indicate integrated system problems that require professional diagnostic equipment. Electronic brake system integration issues involve computer networks that need specialized scanners to diagnose properly. Master cylinder internal repairs require specialized tools and experience. Brake system bleeding after component replacement must be done correctly to prevent air in the lines that can cause brake failure. Remember, brake systems are safety-critical components. When in doubt, consult a qualified technician. The money you spend on professional diagnosis is insignificant compared to the cost of an accident caused by brake system failure. Your family's safety is worth more than saving a few dollars on diagnosis. But even after you solve your brake warning light problem, there's one maintenance mistake that destroys brake systems faster than anything else. This mistake is so common that I see it almost every day, and it's costing car owners thousands in premature brake replacements. Following this diagnostic sequence will identify 95% of brake warning light causes and save you hundreds in unnecessary repairs. Start with the simple checks like fluid level and sensor cleaning before moving to more complex diagnosis. Most problems are simpler than you think. Document your findings as you go through each step. Take photos of what you find, write down test results, and keep receipts for any parts you buy. This information becomes valuable if you need professional help later. Don't skip steps thinking you know what's wrong. I've seen too many people jump to expensive conclusions when the real problem was something simple they overlooked. The systematic approach works because it eliminates possibilities methodically. But brake warning lights are just one of dozens of dashboard symbols that can appear on your vehicle, and most drivers have no idea what half of them mean. Some indicate minor issues you can ignore temporarily, while others signal problems that require immediate attention to prevent catastrophic damage. Click the video appearing on your screen to watch Car Dashboard Warning Lights Explained, what they mean and what to do. I'll decode every major dashboard warning light, show you which ones mean stop driving immediately, and reveal the ones that are just trying to get money out of your wallet. Understanding these symbols could prevent thousands in engine damage and keep you from being stranded on the side of the road. Don't let a simple warning light turn into a major safety hazard. Take action now. Follow this diagnostic process and keep your family safe on the road. Your brake warning light is trying to tell you something important. Now you know how to listen.